us a scenic route across various emotions and how to detect them with kids and how that may improve their software. Am I saying that right?
Yes, yes.
Please give it up for Roger.
That's okay? Yeah, can you hear me? Okay, cool. So thank you, Jeroen, for inviting me to talk here, and thank you all for coming on this warm evening, although I guess the inside temperature is more tolerable than outside, so good for you, good for us. My name is Roger Smeets. I work as a data scientist at Schoola. Schoola is an online educational platform that targets young kids between 4 and 12 years of age. And our mission is to make learning fun. So fun learning is a tagline. You can see the logo in the bottom right there. Leuk leren in Dutch, right? So this is going to be a bit of a different talk from the one that you heard before. For one thing, I actually have colors on my slide, lots of colors. So you're going to see that because it's, well, you'll see why. Jeroen asked me that it might be a good idea to show you a commercial because we are a for-profit company, so we also run commercials every year, actually around the end of the summer holidays when school starts. I apologize up front, it's in Dutch, so if you don't speak Dutch, there's also a bit of English in there, but you'll see. Yeah?
Nog 3 dagen, dan ben ik jarig.
Is the bicycle already in?
Yeah, we got it.
Oh, vet! Dus ik krijg een nieuwe fiets.
Waar halen ze het vandaan? Schoola, leuk leren werkt. Daar wordt ieder kind wijzer van.
All right, so I guess you got the gist of that, right? So I'm not going to explain it further. I debated whether I should give you a live demo of the platforms. I decided not to because usually what happens is that I get carried away clicking around the platform and that takes me 10 minutes. So instead, I made a screenshot, which is the kind of low-tech version of that. What you can see in the right is so this is the homepage that kids will enter when they log on to the platform. This is the web version. We also have a native app. And this is what they see, right? So, and on the right-hand side, you can see a drop-down. I actually expanded it for the purpose of this presentation. Usually it's collapsed, so it doesn't get in the way. That allows kids to choose in what grade they want to play. So this kind of has all the groups, the grades in the Dutch educational system. This is important to know because essentially what this means is that kids are free to play whatever they want, right? A 12-year-old kid can play content in group 1. A 4-year-old kid can play content in group 8. They can pretty much do whatever they want. Once they've chosen a grade to play in, they can go into the platform, let's say, click on a subject, maybe language or soccer. This was a campaign that we ran because of the Women's Soccer Championship. And then when they drill down through the content tree, eventually what they'll end up doing is they end up in a quiz, which typically has a set of questions, usually 10, and they can answer those questions. If they answer correctly, they earn coins and points. You can see them on the top of the screen over there. And with those coins, they can buy avatars for their profile picture. You can see mine very small in the top right there. But they can also buy do-it-yourself goodies like paper cut animals that they can print at home and then make. And they can even buy vouchers for toy stores or even for the cinema. But you need a lot of coins, right? I've been playing for about 2 years. If you want to buy a cinema voucher, you need about 25,000 coins, so you have to play a lot, right? We're not stupid. Importantly also, whenever kids start to play quizzes, they can always choose to quit whenever they want and kind of go back to the screen or somewhere else and do other stuff, right? So it's completely a pick and choose type of setup. There's no constraints whatsoever on what they can and cannot do. So we sell subscriptions to parents. Parents buy it for use at home. So this is like a B2C type of business. Let me give you some fun facts. We currently have 145,000 paying users. So these are kids that use the product at home. And this is where we make our money. And this is all Dutch consumers. We also are used in the school, but for the school it's free. So if you can demonstrate that you are a bona fide Dutch teacher in a Dutch primary school, you get a free account. You can also get your students free accounts that they can use during school time. So usually on weekdays between 9 a.m. and 3 p.m. outside of the holidays. Currently we have about a bit more than 200,000 active school users, so that have logged on and played to some extent in the past 3 months. Next to this, we also offer products to niche markets. So we have a product for kids who are dyslexic or who have spelling disadvantages, which is called Taal Extra. We have a product for people with vocabulary limitations, which is called Woord Extra. We even have a partnership since last year with a US company called Bitsbox that teaches coding for kids in JavaScript. So we offer that for the Dutch market as well. So these paying users, the paying users and the school users together answer on average about 1.7 million questions a day on our platform, which is quite a lot, but you can imagine this is an average. There's quite a bit of seasonality here that typically runs with the development in the school year, right? So in August, September, we see all these metrics spike, then it kind of winds down towards the end of this calendar year around Christmas, and then it kind of jumps back up at the beginning of the calendar year after the school starts in January. Math, language, and spelling are pretty consistently the 3 top most popular subjects that are played most by the kids, both at school and at home. And because of the weather, we've done lots of analyses with these data. One of the things that we found is that temperature and play correlate negatively. So you can imagine that these days are not good for us, the engagement, but at least kids are apparently going outside and play, right? So that's good for the kids, I guess, and their health. All right. So before I dive into today's topic, I wanted to give you a brief overview of what data science entails at Schoola. I try to cluster what we do around 4 topics, a bit artificially, but I guess it kind of covers the spectrum. A lot of what we do is just provide business support, right? And I guess many of you who work in the data science departments in your companies are very familiar with this. This runs from small things like helping people write queries, building dashboards, maybe also sometimes trying to figure out what are the drivers or particular phenomenon that people are interested in, to more bigger projects like building a churn model or doing analyses on NPS scores, Net Promoter Scores. It's very important, big work, but I guess not fundamentally different from what you would see in other companies, right? What is more specific for our platform, it's a learning platform, is that we think and work a lot on adaptive learning. So part of our platform, it's a small part, but the growing part is adaptive, which means that the difficulty of the questions that we offer to kids adjusts with the capability of the kids themselves, right? And to do that, we have an algorithm running in the background, which is an ELO algorithm. So if you're familiar with chess, or if you are familiar with any other type of tournament setup, these ELO algorithms are typically used to either match players of similar capabilities or to predict outcomes of a match between 2 opponents, right? So in our platform, a match is essentially a match between a kid and a question, right? The question is answered correctly, the kid wins. If not, so we use this algorithm to predict what the likely outcome of such a match will be. We then see, or we observe what the actual outcome was, and the difference between the two gives us some information to update both the ranking of the player, of the kid, as well as the ranking of the question, right? And so we use this to move kids up and down the ranking ladder, as well as questions, and that helps us to offer them content which matches their capability. Another important topic is efficacy. This is about us trying to figure out if kids play Schoola, or a lot of Schoola, does it help them to perform in school? Does it help their school performance? It's an easy question to ask. It's a pretty difficult question to answer, as you might imagine. First of all, school performance data are either owned by CITO in Holland or by the parents. It's very difficult to get access to. It's also something that parents are really protective of, rightfully so, I guess. Even if we would be able to get these data, you might still imagine that, in particular for our home users, there's a lot of stuff we don't know, right? So there's a lot of stuff we can control for. The one particular confounding factor being school itself. Hopefully, school performance is in large part driven by the school. And so we continuously try to think of ways to get around these issues and still be able to try to demonstrate the effectiveness of the platform for performance and school performance in particular. So that's a big task of our team as well. And then finally, and this is kind of related to the topic that I want to talk about today, there's user engagement. Now you might say, well, that's again pretty common for any subscription-based business. This is a subscription-based business, right? We sell subscriptions monthly or annual to parents. And that's true, right? To some extent, that the engagement, tracking engagement, trying to drive engagement is very common for these kind of businesses. But I want to argue that in our case, user engagement is a little bit broader maybe than what you might typically expect. And let me explain. So when we first started thinking about what defines engagement for us and what do we find important when users interact with our product, we quickly stumbled upon this notion that yes, we do want to know something about how intensively kids use our product by looking at what we call behavioral engagement, which is just how long do they play in the platform, how often, how regularly. That's all important, but it's probably not enough, right? We could have kids coming to our platform on a daily basis and just keep repeating the same quiz to mine coins and eventually be able to buy that cinema voucher. Cool for the kid, not so cool for the learning, right? We are a learning platform, so we do want kids to be exposed to new things and to learn something while they practice on the platform. So we also figured that we need an additional component to this engagement model, which is a cognitive component, right? When kids come and play, they should also be exposed to new stuff so that they actually learn something, and that new stuff should be offered to them at the right level, right? Shouldn't be too easy, because then nothing is learned. Shouldn't be too hard either, because then behavioral engagement goes down, right? So there's this tension between these two. But again, probably not enough, right? Because the mission of Schoola is fun learning, right? It's not just about getting there and learning, it's also about having fun, right? We use game mechanics, we use design, we use popular content to offer a fun experience to the kids. So we probably want to make sure that we actually offer that fun experience. So there's also an emotional component to this. When we were discussing this third emotional component, we kind of got stuck a little bit. You can imagine that we log a lot of things that these kids do, right? We have play logs of pretty much everything that they do. We store all that data in a database. For these first two components, these are pretty straightforward to calculate, right? It's not tough, it's not tricky. But how do you derive fun, whether kids are having fun from play logs? It's pretty difficult to do, right? So we took a while, we mined some data, we correlated patterns in play behavior with churn, with the other two engagement dimensions, with parent feedback, all those kinds of things, eventually to arrive at two metrics that we proposed to our management team. The first one being play interruption. So our thinking is, if you're playing a quiz, and at some point you're not finishing it, but you choose to close it without finishing, something must be up, right? Something must be going wrong. Apparently you are not having a good experience. This probably, in our intuition, demonstrates a lack of enjoyment, right? So we propose that this would be probably a good metric to look at if we want to say something about the extent to which these kids are having fun on the platform. The second one was what we call excessive navigation. So these are kids that just spend time roaming around the platform, going to the goodie shop, going to look at their avatars, looking at the leaderboard, clicking through the content, but not playing, right? Not playing. And this platform is for playing and practice. So our thinking was, well, if they're doing that, probably they are not able to find the stuff that they're looking for, which must be quite frustrating. Maybe there's a UX issue or something. So we were pretty content with ourselves, right? We cracked the nut, right? We had our two proposed metrics for tracking emotional engagement. As you might imagine, we got a lot of pushback on this. As I was just telling you these two metrics, you may already have some critical thoughts yourself, because of course, lots of other stuff could be going on, right? For instance, kids might interrupt their play not because they're getting frustrated, but because the parents are calling for dinner, right? That's a fairly valid thing that might happen. And second, some kids might just like roaming around the platform, looking at avatars, right, or looking at the goodie shop, dreaming of what they might buy with their collected coins, which is not necessarily bad, right? If that's fun, fine. If that's the way you want to use the platform, fine, right? Sure, it's not good for learning, but that's another engagement metric. This is about having fun. So they told us, if you want to sell this to us as two metrics that we should track, go back and validate them. Get some objective data for fun and tell us that these metrics correlate with those objective facts, which was a bit of a downer, because if we would have those data, then we would have probably already used them, right? So we didn't. But what they were essentially asking us was label the data, get some labels to determine whether kids are having fun or not, or what kids are experiencing when they are playing on the platform. So again, we got stuck a little bit. We weren't quite sure what to do, and so usually what we do when you get stuck, we kind of look at others, because others have usually thought of something before us. So we stumbled upon this field of effective computing, which is a huge field I didn't know about before. And there's also a pretty big branch of that in the area of education. And so there, a bit of time is spent on thinking about how do you label data? How do you label play data in such a way that you know how people are feeling at different points during their play experience. So it's called affect labeling. Affect is just a pretty word for emotional states or emotion. There are two main approaches. The first approach is this: student monitoring by expert observers. This is not a random picture I took from the internet. It's actually a pretty famous guy in this field of study. It's Ryan Baker. And here he is holding a device which is linked up to a server. He walks around a lab or a classroom. You see all these people sitting behind the terminals. Those terminals are linked to the same server. And so what he does is he will pick out a person, choose the terminal number that is displayed, and then observe the person and think, well, this guy looks pretty frustrated. Bam, right? Or something else. And so what that gives you at the end of the day is a bunch of play logs intersected with labels of affect, of emotional states, which is great because that's what you need, right? Neat, obvious, but not good for us. First of all, this is pretty labor intensive, right? Because you actually need people to do this. It's also fairly technology intensive because you have to set up the entire thing. But most importantly, it's not good for us because what we need to do this is to get kids into a lab or into a classroom and then have a person or two people walking around observing them with a machine and just recording what they're doing. So think about this, right? This is a product that is intended for use at home, which is hopefully the most secure place for a kid in the world. Now you take that kid, you put him in what is probably the least secure place at that point in the world, which is a lab at school lab with some person walking around, and then we're labeling these data. Even if we get the labels right, probably the play experience that we observe in that lab is not going to be representative at all of what it would be at home, right? So this was out of the question pretty quickly. And then the second approach is just give them a survey, right? Either online while they're playing, just ask them at various points in time, how are you feeling? Or do you agree that you are happy or frustrated? Or at the end of the play, just ask them in a long survey what they were experiencing while they were playing. Again, pretty straightforward, but also problematic for us because, first of all, kids between 4 and 7 years of age can't read, right? Or can't read well. And second, most kids between 4 and 12 years of age are pretty much turned down when they see lengthy pieces of text, right? They kind of ignore them. So that would probably give us a huge non-response bias here. So fair enough, we thought maybe let's dig deeper and see if something has been done for children. Like how do you get emotional or affect labeling for children? But there was nothing, which if you're an academic researcher is great, right? Research gap. But if you're in industry, it's pretty shitty because what do you do now? So we decided to do it ourselves, to come up with an instrument for affect labeling. Which is essentially an effect reporting instrument. First, we found out that in the area of usability software testing, so this is people that present pieces of software to users and try to figure out what their experience is using the software, we found out that in that area, there's actually stuff on kids. In fact, there's this smileyometer, and this is it. This smileyometer, yes. What is the smileyometer? It's essentially a 5-point Likert scale, but instead of the points, you have smileys. And then you ask, how much fun was that? And kids choose a smiley. Not sure about you, but I was a little underwhelmed by this instrument when I finally stumbled upon it, because so apparently this is it, right? This is what we can do. And again, we found out through additional research, but also testing of our own, that this is not really, that it doesn't work well, again, with young kids, because young kids can't differentiate well between intensities of emotions, right? They don't really know intuitively the difference between the awful smiley and the okay smiley, or the okay smiley and the fantastic smiley. And they can't read, again, right? So they can't read the words either. So, still not much luck. So, what we also found out is that even though kids, in particular young kids, have difficulties differentiating between intensities of emotions, what they can do is differentiate between types of emotions. So they do know fairly clearly the difference between happy and sad, or happy and angry, or happy and frustrated, right? So we use this to build our own instrument. What did we do? We are trying to detect 4 emotions, 4 affective states: joy, boredom, confusion, and frustration. These are not just random. As it turns out, these are the 4 emotions that are significant correlates of learning paths and learning effectiveness, right? If you want to understand how emotions affect learning, then these are the ones that you want to look for. So what we did is we took these 4 as our baseline, And then we have, luckily, a design department. And we ask these people, okay, go design some emoticons, some smileys, emoticons because they're not all smileys, of course, that capture these emotions, right? Tell us what you think should be done. So they did. We took those emotions. They designed a bunch, I think 3 per category, so we had 12 in total. We took them to adults first, and we asked them, all right, look at this emoticon. Tell us what you think this emoticon is feeling. And pretty early on, we got consistent feedback. Like, the adults agreed on everything. Like, oh, this one's happy, this one's sad, that one's confused, that one's frustrated. But of course, again, we're designing for kids, right? So we took it to kids. Completely different ballgame. For instance, what is this emotion? Well, if you had to guess. Yeah, of course, I primed you a bit, right? Confused, yes, yes. We didn't hear it at all from the kids. We got 2 answers, nauseous and dizzy, right? These are not even emotions, but the kids don't care, right? The kids don't care. That's what they told us. So nauseous or dizzy, which wasn't very helpful. And this was the one emoticon that really stood out. There were more, but eventually what we ended up with were 8 emoticons that were okay-ish in terms of interpretation. So these are the 8. A for happy, B and C for confused. We had 2 because we couldn't really get clear convergence in our small one-to-one testing. D and E for frustrated, again, because of some confusion. In particular, young kids think this is snot, right? So problematic. F for bored, G for sad, and H for surprised. Oh, and I should mention, we have G and H, not because that's something that we wanted to detect, but we also want to have some detractors, some detractor emotions, because what we then did is we went to our platform, we designed 2 quizzes. In the first quiz, we would show one of these emoticons in each question, and we would ask kids to tell us, what is this emoticon feeling? In the second level, we would ask kids, which of these emoticons do you think is happy, or bored, or sad, right? So this was pretty cool, because now we could roll this out on our platform, and now we get huge responses, right? Eventually, we ended up with about 22,000 kids responding to these quizzes that we developed, which is pretty neat, right? Because that's not something you easily get from one-on-one testing, at least not within 20 years or so. Before I move on, I just want to show you a typical pattern that emerges, which again illustrates the problem of working with, or the issue of working with young kids. So, like I said, in the second level of this quiz, we would ask kids to identify 1 out of 5 emoticons that corresponded to an emotion. One of the questions that we asked, which emoticon is bored? And we showed frustrated, sad, confused, angry, and bored. So, frustrated, sad, confused, angry, and bored. So it's this one, right? That was the one that we're looking for. And what you can see is the response shares for each grade. So there on the top left, you have, well, that's kindergarten, so it's the first grade, and this is grade 8, group 8, actually, in the Dutch system. And so the orange bar is what we intended, right? You can see that older kids, it's clear, right? They understand what we are trying to convey with this emoticon. But the young kids, well, eventually, the majority of kids still knows what we intend, but there's much less skew in their response shares, right? So you can see that they have much harder time understanding what we mean. I'll come back to that when I show you some results of the predictors that we built. Eventually, we did find that these 22,000 kids that responded to these emoticons converged on 4. So we had 1 for happy or joy, bored, frustrated, and confused. So what we did is we designed a modal. This is the modal. It's a modal apparently is a fancy word, modern word for pop-up. So that's it. And we would offer it to kids while they were playing, so at playtime. Now, as you might imagine, our UXers tend to not be very happy when you just throw random modals in people's faces because they think it hurts the user experience, and I think it does. So we had to decide when do we want to show this modal to kids, and we essentially used this to verify or falsify our hypotheses about the 2 metrics that I proposed earlier, right? So we had 3 triggers that trigger the modal. First, when a kid finishes a quiz without interruption, that's kind of the benchmark, because we suspect that that's actually an enjoyable experience, right? You go from start to finish in one go, so something must be going well. Second, that's the first metric that we proposed, when a kid interrupts a quiz, right? That's the first metric we proposed. And second, or third, when a user has been navigating the platform without playing for at least 3 minutes, right? So excessive navigation. So that's when we offer these modals. Not all the time. There are restrictions on how often a user can see this modal per week. Again, not to disrupt the experience too much, but these were the triggers. So let me first show you what we saw in terms of descriptives, right? So here you can see the 3 triggers in the columns: quiz completed, quiz interrupted, excessive navigation. Over there you can see the responses that people clicked on, so happy, bored, confused, frustrated. They could also choose not to answer, just close the modal without answering, so we also included that. And what you can see is that these kids that complete a mission indeed are predominantly happy, right? They have an enjoyable experience. In fact, if you leave out the not answered category, which essentially is useless anyway, this number even increases further, right? So that's pretty good. It's also really different from when kids interrupt the quiz or when they're navigating, right? That's clearly a less enjoyable experience. So that was one thing that stood out. Another thing that stood out is that when they interrupt the quiz prematurely, without finishing it first, they're much more likely to be frustrated than when they complete it or when they're navigating, right? So that's another thing that stands out. It's not only the case that they're not having as much fun, apparently they're getting more frustrated when they're quitting a quiz. And third, we saw that when we give this modal when kids are just navigating, a lot of them don't answer, which was kind of weird, right? Why would that be? Why would these kids choose not to answer more often? I actually stumbled upon the reason myself. At some point I was testing some functionality in the platform. I did something else, checked my email or something, went back to the tab after a couple of minutes, and the modal was in my face. And I'm actually the guy who thought of all of this, and I just instinctively clicked it away, right? Like, get away. And I decided, right? I even closed it. So that's what was happening. So what we then did is we splitted the web versus the app players. And indeed, you see that the web players, they are the ones that kind of ignore the modal a lot, and the app players are just very similar to quiz completed. The app players are very similar to quiz completed, which actually tells us that kids that are navigating are not more or less happy than kids that are just completing a quiz, which falsifies the second metric, right, that we had in mind. All right. Now, so we build a couple of fact detectors. What we try to do is to see if we could also validate these metrics in a more formal fashion, not just looking at these descriptive statistics. And we also tried to see if there was other stuff that could be predictive of these emotional states. So we built 4 classifiers. It's always one versus the rest, right? So it's happy or not, it's frustrated or not, it's bored or not, or it's confused or not. We tried a couple of different algorithms to see if that might matter. We did student-level splitting between training, testing, and cross-validation because we want to make sure that we can also predict this for students that are new, that we haven't seen before, right? So that was an important feature as well. We had about 51 features. I have to say this is still work in progress. So as you can see, the performance of these models is okay-ish, but it's a hard problem to tackle, as you might imagine. Of course, we had the trigger type in there, right? Because that is one of the metrics that we want to propose to monitor as a first step towards detecting these emotional states. One of the other things that we had in was to see how many questions these kids have answered correctly before they gave the response. And what you typically see is that, indeed, answering a lot of questions incorrectly tends to lead to a frustrated interruption of play, right? Which is what you probably intuitively would expect. So these are the models we optimized on the kappa statistic. I'm not going to spend too much time here, except to show you that we're doing pretty well in terms of predicting or modeling happiness and frustration. We're doing a pretty lousy job in modeling boredom and confusion. And there might be a good reason for this, because as I showed you, these 2 emoticons were actually not that clear-cut for young users in particular anyway, right? So maybe the instrument is just not very well calibrated for this particular case, right? Maybe we're doing a better job measuring what we intend to measure with happiness and frustration. As I told you, what are important predictors here? The trigger type, which is again, it underlines the validity of that metric that we proposed, interrupted play. If kids complete a level, they tend to be happy. If kids interrupt a level, that correlates significantly with frustration, right? So this is kind of where we are now. And the question is, how do we continue? So we like to keep things simple. We don't necessarily model for model's sake. And also our management team is a bit weary still of all these automated detectors. So what we proposed is to first monitor play interruption, because I think we have kind of established that if not a generally applicable metric, it correlates with frustration and with a lack of enjoyment enough to to serve as a proper metric to monitor, right? So that's something that we're doing now. We're in the process of developing hypotheses to think about what are some things that we can do to get this interruption share down, right? That would be a good first use case to see if we can actually steer these users away from a negative experience and towards a more pleasant experience, because if they stay longer, there's more opportunity to learn, right? Eventually, we would like to be able to detect or predict when a kid is likely to interrupt play, because if they do, we might offer them a nice intervention, right? We have bonus games, we have mini games that they can play that might serve as comic relief. So that's something that we also want to A/B test in the future to see if we can get an even more fun experience for the kids when they play on the platform. All right, so that's it. Thank you. Also, we are hiring, so if you want to know more about that, talk to me.
Thank you, Roger. Any questions? Vincent.
So I used to work for a startup in the education space as well, and we at some point had this weird thing where we were sort of wondering if we train people for the CITO tools, are we not removing the value of the CITO tools? Like you can train towards a certain test.
Training towards test, yes.
But then if half the population sort of is able to train it, the other half isn't, you kind of get this weird unfairness thing. What's your philosophy on that?
There's the fairness thing again. So essentially, this is, well, I guess it's true to the extent that we do have test trainers in there, right? So we actually have content that specifically trains for the test of that nature. So it's not training for a particular test, it's just practicing stuff that you've already learned at school. But I think you're right, right? To some extent, there is a degree of unfairness because you have to be able to pay up the money to be able to afford the software. On the other hand, we do have these Schooler for free at schools, right? So essentially everyone who is at school has access to this. And we have these free products which are geared towards vocabulary limitations, which we definitely offer with exactly this thought in mind, to get kids that have a disadvantage already at early ages, to get them back up to speed with their classmates as soon as possible. So I guess, yes, there is a bit of that, definitely, but we are trying to do good as well as make a profit. Sorry, I can't really hear. Could you maybe stand up? Yes. You mean the response time that they take to answer a question? Ah, yeah. Yes, like spaced learning.
Could you repeat the question?
Yeah, so the question is whether we also take into account the time that kids take between answering questions, because maybe at some point they might forget stuff, and then so they have to relearn it again, and so that could influence their capability and the way or the extent to which they can answer questions. Is that correct? Yeah. So no. That's an easy answer. So this model that we have implemented is it's like the most basic form that you can think of. It's a one-parameter rash model, essentially. I'm not sure if you're familiar with that. It sounds like you're pretty familiar with that literature. Modeling forgetting, modeling guessing, modeling slipping, or modeling getting lucky, right? Those are all kind of extensions that you could apply, but that also takes you to a different algorithm altogether. So you get into the realm of Bayesian knowledge tracing and those kind of things. It's something that we are exploring, but it's the reason that we chose this algorithm is because it's computationally very inexpensive. And so it can run in real time as the kids play. And for BKT, Bayesian knowledge tracing, that seems to be, that specific issue seems to be more problematic. Thanks.
One more question, or two more? Yeah.
Oh, actually, I have two things.
You have two things.
So I'm,
Okay.
can only choose one, right? I can go for both.
Do it quickly.
Okay, real quick. So the first thing is actually because, you know, like normally, like a kid's development, actually when you're really young, you cannot, like what you said, you cannot actually identify the emotion. They don't even know themselves. But what I understood from you is that you apply all the icons from the youngest age you can play until, I don't know, like grade 6, if I'm correct?
Yeah, so
All the
grade
way.
6, group 8, yeah.
So doesn't it make sense if you actually segment them in a sense that, you know, for the young kids, you have to work for properly professions that actually to see what kind of emotions they would have at that stage. Instead
Yeah.
of giving them all the icons, because now you totally see the results are completely different.
Yes.
So I'm not sure, maybe that's something you're already working on?
Yeah, so you're right. So what we concluded from this exercise is that if we want to repeat this again, that we should probably offer the younger kids a binary option, like happy or frustrated, or happy or not, right? Instead of all like this rich variety of emotions, which apparently only works for the older kids.
Maybe even better to see actually how many emotions they actually can identify before you actually give them all these like availabilities, right?
Sure, but that's tricky to do if you have 145,000 users,
Well, fair enough.
right?
Okay, real quick, second one is that do you know the application of the platform Super Memo?
Sorry, Super Memo?
So go and check it because it's really interesting. So basically it's for people that if you want to, you know, make cue cards, so you can type like, you know, question, answer yourself, and then the cards will popping up, and it depends on how well you answer each question. So say you answer the same question correct 5 times.
Sure.
It will pop up again properly. It takes
Yes.
longer time to pop
Yeah,
up.
yeah.
So it's probably related to what
Yeah.
you said about interval.
Yes.
But then it actually might help the kids to keep, if they want to collect coins, it won't work. So the more they answer it, maybe it'll take 1 year before the same question pop up.
So the restriction that we now have in place is that you don't get the same question for the next
Gotta
20.
answer a different
Well,
question.
you have
to work hard and, you know.
Yeah, so the logic we have now in place is that you don't get the same question in the next 20 rounds.
Chinese way, you gotta work for it. Yeah, you can't. Sorry. Yeah, but thanks. Yeah, that's why.
All right.
Yeah.
Is there a correlation, possibly a correlation between quitting and going to bed or going to eat?
The time of day, yeah, definitely. So we checked indeed whether around. It's always tricky, right? Because we had this intuition, or maybe around dinner time. That's when this stuff kind of happens. But then you have to define dinner time, which even if you ask around, like some people, well, it's Holland, so people typically eat between 5 and 6, right? But especially people with kids. But there's still such a degree of variation that it's. I think there's more noise than signal there in that. Yeah, at least that's what we found. I think I have to stop answering questions, but we can talk offline. Thank you.
Thank you, Roger.